welcome to PASC26. This is the highlights from the mini symposium. I'm here with Ludovic Rees from University of Lausanne and Samuel Omlin from the Swiss National Supercomputing Center, CSCS. You were co-organizing a mini symposium about Julia for HPC, enabling co-design in scientific workflows. So the obvious question is, why did you organize such a mini symposium, and what were your expectations when you submitted this mini symposium?
Yeah, so the idea behind is that, well, there is more and more traction with the Julia language in the HPC landscape in general, and the Julia language is kind of excels somehow because of its like modularity, flexibility, like the way it's designed to actually enable, well, co-design, and that's why we, in scientific workflow, and that's what, well, we gather speakers to exchange a bit about this idea, like in that kind of current setup of heterogeneous everything, a bit in the HPC landscape, and that's what we were like interested to investigate and hear about.
But then the obvious question is, what are the challenges that you are trying to address with Julia, and I assume the advantages of using Julia?
Yeah, I mean, now there are big challenges coming to the Julia community, but to everyone, because the hardware landscape is really changing, pushed by AI. It's going towards less and less precision, and we need to deal with that. And we need to be able to use the latest accelerators that are coming to the market. And so I think there has been done really good steps forward. Besides that, we had some nice applications in our mini symposium. One was oceanic, and about climate, and the ocean in particular, and another one about it was just relax geodynamics. We had some very talks that really addressed this particularly. One was a reactant, which would describe how we can go from Julia code to via MLIR to machine code. MLIR is pushed by AI, the AI market. And on the other side, we had also about linear algebra, latest advancement using lower precision. So we really had the most important aspects quite well covered in our mini symposium.
So then it was, I have to conclude that you had not only very interesting presentations, but probably also interesting discussions, but then not to lose the momentum that you have created here at the PASC conference. What would you like to see happen? Ideally, what would you like to see happening in the next months, maybe until the next conference?
I guess we're on a good start, and kind of the motto could be for a following period is like do more with less, like maybe with mixed precision, lower precision, but also like less burden for like the main scientists to actually be able to have their code, that the code you write is not the code that you want to run actually. And yeah, and this all is kind of, now we get like tooling and initiatives well, within PASC project, like our GPU4Geo project, that actually have people to exactly address this, and like which slowly shows results. And so we're excited to see that kind of, getting more advanced.
Well, the problem of lower precision now is coming because the new generation of hardware we have seen, we will be forced to deal with lower precisions. And so the HPC applications have to start really addressing this problem. Thank you very much for joining us. So good luck then for the next steps, and maybe I will see you again next year, PASC27.
Yeah, hopefully.
Thank you very much.